Welcome to Spring LIB.
So we're given an ellipse, and we're going to find the two tangent lines that pass through the point 12, which is not on the ellipse, as you can see by the picture there. So what we're looking for is the two lines. This one looks like it's probably going to be a horizontal. And then the second one, that looks like it'll pass somewhere over here. And what we want to do is find the equations of these lines. And what we want to do first is find the slopes. And then we have to find out what these points are on the ellipse that are actually part of the ellipse, to find the equation of the line. So in order to find the slope, it's going to be the derivative of this function, y prime, right? So we need to find as y prime, and we're going to differentiate this implicitly. So basically, we'll treat x's like we normally do, and then anywhere we have a y, it's going to get a y prime attached to it. All right, so derivative of x squared is just 2x. Derivative of 4y squared is 8y, but then because it's with respect to y, we get a y prime, and then the derivative of 36 is 0. Now what I want to do is I want to solve for y prime because I want to find the slope, right? So I want to isolate y prime here. The way we'll do that is we'll subtract 2x from both sides, and we get 8y prime equals negative 2x. Divide both sides by 8y, and we get y prime equal to negative x over 4y after we simplify, and I know that that's also the slope of the line. Now, I also know that I can find the slope using just the regular slope formula, y2 minus y1 over x2 minus x1. And I know my point here is 12,3. And I know that some equation, some point on the ellipse would be x1, y1, or x2, y2. And so we'll just call this x1, comma, y1. So then I know that this is going to be equal to y2 minus, and we'll just call it y instead of y2. We'll just call it some random y minus 3, because that's my y1, over x minus 12. And I know that that's also equal to my expression that I got when I solved for y prime. So that's equal to negative x over 4y. And now what we can do is cross multiply here, because I have two expressions that are fractions that are set equal. And we wind up with getting 4y times y minus 3 equals negative x times x minus 12. So this is 4y squared minus 3y equals negative x squared plus 12x. And the trick to this is, I know this expression here equals 36. So if I can find an x squared plus 4y squared in my equation down here, I can replace it with 36. And I can in fact do that if I add x squared to both sides here. So we get 4y squared plus x squared minus 3y equals 12x. This should be 12y. 12y. And then I can now replace this piece here with 36, because that's my ellipse equation, minus 12y equals 12x. And now what I want to do is I want to solve for x, so I can then plug it into my ellipse equation. So I'll divide both sides by 12. And this side simplifies to 3 minus y equals x. Now, if I go to our ellipse equation, because I want to find a point on that ellipse, 4y squared plus x squared equals 36, and I replace the x with the expression on the left, we have now 4y squared plus 3 minus y squared equals 36. Or 4y squared plus 9 minus 6y plus y squared equals 36. Now this is quadratic, so what we want to do is collect everything on the left, set it equal to 0, so we get 5y squared minus 6y plus minus 27 equals 0. And then we're going to use the quadratic formula, so your y equals opposite b plus and minus square root b squared minus 4ac over 2a. All right, so that's going to give us 6 plus or minus square root of negative 6 squared minus 4 times 5, negative 27 over 2 times 5. And this simplifies to 6 plus or minus square root 576 over 10, which gives us two solutions, y equals 3 and negative 1.8. Oops. So now what we want to do is find the x's associated with that. So if we go back over here, 3 minus y equals x. So if I plug in y is 3, 3 minus 3 is equal to 0. So then I know the point 0, 3 is one of the points on my ellipse. And then 3 minus 1.8 equals x. So that gives us 1.2, or 3 minus negative 1.8. So that gives me 4.8 then. So then I know the point 4.8, comma 1.8 is also on the ellipse. And now to find the equation, we can just use y minus y1 equals mx minus x1. And I know from earlier m is equal to negative x over 4y. And we'll just plug both of these points in. So if we use 0, 3, we have y minus 3 equals negative x is 0 over 4y is times 3 x minus 0. This whole side becomes 0, so we just get y minus 3 equals 0, which gives us y equals 3. So that's the horizontal one that looked horizontal when we looked at the picture. This is y equals 3. And then the other line, we're going to use the point 4.8, 1.8. So we have y minus 1.8 equals negative 4.8 over 1.8 x minus, is this negative 1.8? This should be negative 1.8. So then this will actually change this to plus, and that's a negative there. 4.8 here. And 4.8 divided by 1.8 is 2.67, so let's make that a fraction. 8/3. So this is y plus 1.8 equals 8/3 x minus 4.8. And it looks like I forgot 4 here. Let's back up here. Getting a little messy. So there, I forgot the 4 in the denominator for the slope here. So this is 4.8 negative over negative 1.8. Now the formula in it has a 4, so I have to multiply that by 4. So this simplifies to 2/3 when we do that. So now we simplify this. This is y plus 1.8 equals 2/3 x. 2/3 times 4.8 is 16/5. And then we'll add 1.8 to both, or subtract 1.8 from both sides. And we get y equals so minus 1.8, turn that into a fraction, 7/5. So it would be 2/3 x minus 7/5. Right. Check that. I put the wrong sign in my calculator. Negative 16/5 minus 1.8 is -5. All right, so the two equations then, after this long and winding problem here, are y equals 3, which again was the horizontal, and y equals 2/3 x minus 5, which if we again go back to the picture, is the second line here. And it looks like it goes through -5 pretty nicely there.